All right, write that problem down. This is the problem I was looking for when we were finishing class the other day. It's the problem about the roulette wheel. You might see one like it on your test. The modified roulette wheel has 36 slots. One slot is 0, 0, and the other one is 0. If some of you don't know what a roulette wheel looks like, just to show you, because I had people in my last class that didn't. That's a roulette wheel. There's the 0 and the double 0, and the other numbers here and here. So that's what a roulette wheel looks like. I gotta find my question again. Okay. Now this question is somewhat straightforward, but some people kind of get confused with it. first of all, you have to think about what is success. You are placing a bet that the outcome is a what? Odd number. So success is going to be the probability of an odd number. And the probability of an odd number is going to be 17 over 36. Now that much is pretty straightforward. 17 over 36. The part that's not straightforward is the next part, because with success comes what? Failure. And the probability of not odd is equal to what makes up the complement of 36. And what will that be? 19 over 36. Remember that you have to equal 36 in the numerator as well as the denominator. The denominator is 36, but the numerator has to equal 36. And why is this one 19? Because the only odd numbers are half of 1 through 34. 1, 3, 5, 7, 11, 13, 15, blah, blah, blah. Okay? Why don't we include these? They're neither what? Odd or even. Okay, so I can't include them with the odd because they're not odd. And I can't include them with the even because they're not even, so I have to say they're in the not odd. And that is where students mess this problem up. They say 17 here and 17 here, and they get it wrong. This one will not be equal to this one. It will always be 2 more than this one because of the 0 and the double 0. And that's where people mess the problem up. Alright, so your answer to the probability of winning is 17 over 36. Then it's going to ask you the odds against. The odds against are equal to the probability of failure over the probability of success. Leave it in fraction form. In this problem, it's best to leave everything in fractional form because of this right here. So, what's the probability of failure? 19 over 36 divided by 17 over 36. And what do you do when you divide a fraction by a fraction? Multiply by the reciprocal, and what happens to the 36s? And they always will. And that leaves you with 19 to 17 is the odds against. Now, this is one of those things that if I ask people that have taken probability and statistics how that works, half the people out of probability and statistics couldn't tell me. Okay? Because they don't know what it means. So I kind of give y'all a little scenario. You do not have to write this down. Just listen. If I give you a recipe for 24 cookies, and it consists of 1 cup of flour, the main ingredients, 1 cup of flour, 2 cups of sugar, 4 eggs, 2 cups of peanut butter, and 1 cup of milk. And that makes 24 cookies. Subtract the little pinch of salt, a little bit of this, and vanilla and all that, but just the main ingredients. If I ask you to make 48 cookies, what do? How do you know the double? Where did you get that number from? 48 divided by 24, or 24 times 2. You have a multiplier, which is 2. And you get that by taking the number that you want over the number that it makes. So if I ask you to make 57 cookies, then you would multiply all the ingredients by 2.3. The whole point is this multiplier never changes. This multiplier is just like a portion, or a ratio, or an odds and units. So if I wanted to know how much money I would win on a 19 to 17 odds against, if I bet $50, what would I win? Well, you take 19 over 17 and multiply it by $50. Do that. Well, I fixed calibration on this daggum thing. I thought I did it during the 8 o'clock class, but evidently I didn't. Or something happened to it. Must not hit all the dots. So what'd you come out? How much? So you won $5.88. Not much of a bet, is it? Why? Because the probability of winning is about 50%, isn't it? Everybody's supposed to say yes.
It's got really high.
Mm-hmm.
Said $5.
Yeah, you put in 50.
$5
You won $5.
Never mind.
You had a $5 profit.
I got you.
All right, so our probability of winning is 17 over 36. And this is 19 over 17. Now C, everybody should get C correct. Read C. When you bet that the outcome is an odd number, the payoff odds are 1 to 1. How much profit? Now I don't agree with the word profit. I like to say payoff. What is the payoff if you bet $11 and you win? On a 1 to 1 bet, you win $11. It's not profit. I don't like the way they use the word profit. I've fussed about it. I've emailed them, and they just leave it. So I'm not going to worry about it. I would say the payoff. What does the bank or the racetrack or the Las Vegas pay you if you win with a 1 to 1 bet? Well, if you pay them $11, if you bet $11 on a 1 to 1 bet and you win, you get back what? $11. So everybody should get C right, because all you do is put the same number that you get right here. If you don't get C correct, don't tell anybody.
Are you trying to say that you make $11 when the top of the bet today, or
You
you
just get your $11.
Well,
You break even.
I know.
That's why profit is not. That's not
So
correct.
why would you even make that?
That's bet. No. How much profit would you make on your odds against right here? Now, I'm not going to say profit. I'm going to say payoff. How much is the payoff if you bet $11 on these odds? So multiply 11 times 19 over 17. What do you get? Now read the question. It says, how much profit would you make? Well, profit would be what? $1.29? That would be the profit. So I don't agree with this question, because if you were answering the question, you would answer $1.29. But just remember, don't miss this because of the wording. The wording is wrong. It should be how much of a payoff would be made on an $11 bet if the casino used these odds. Now, what kind of odds are they on a racetrack? Let's see if we can find that. Let's go to roulette wheel and let's go to racetrack odds. Betting on a horse for dummies. I just wonder if they give some examples. Okay, there's some odds right there, but that ain't. All right, 16 to 1. That's the I suck horse. Okay. Why is it 16 to 1? Well, that means that this horse ain't got a chance in Hades of winning. But if you find one that's 50 to 1, that's what I was wanting to find. Let me see if I can find real racetrack odds. Real racetrack odds. There we go. Here we go. All right, let's find You Suck. Well, there's You Suck right there, 44 to 1. All right, his name's Two Harry's Holiday. All right, you might as well just put You Suck here. This horse sucks. 44 to 1. So let's say that you just won. You got some money from your uncle or whatever, and you got $2,000, and you bet $2,000 on a 44 to 1. Then you bet $2,000, and if You Suck comes in first, what do you get? Well, 44 times, what do we bet? $2,000. That's 44 times the 88,000. But I'm just gonna make sure you walk out of there with 88,000. But what's got to happen for You Suck to win? There needs to be a sniper up there shooting all the other horses. Or lightning strikes and knocks 4 or 5 of the horses down. Now look at the odds for the other horses. There's 49 to 1. That's the You Suck more. Which one you think's gonna win? There's a 6 to 1. Wicked Strong. Is there better than 6 to 1? Where? Okay, 5 to 2. So 5 to 2 is about what? 2 to 1. 2 to 1 if you was to divide it, about 2.5 to 1. So that's that. I don't know. Is this real or what? Did they win 2014? Wonder who won.
You haven't heard about California?
California Roll was on
You never heard that story? They're from here. They're from
Secretariat.
They're from around here.
Oh, that's good. Did she win
Yeah.
the Triple Crown?
No, they didn't make it.
Well, she sucks.
It's like that close.
Did she almost win?
Yeah.
Well,
You have to look up.
what didn't they like? Wasn't it like a rags to riches story?
Yeah.
Well, that's neat.
They just decided to buy a race
He bought her really cheap.
horse. Yeah.
Well, that's good. I'm glad to see. Let's see if there's any other crazy odds. That 49 is about the worst one. So say that poor horse really sucks. So if you bet $1,000 on this horse and it won, you'd walk away with $50,000. Oh, I'm sorry, $49,000. Pretty good. That's why people play the racetrack. I don't think I could play the racetrack. A lot of, and then if you bet on this horse, let's bet on that 4-1, 6-1. If you bet $1,000 on this horse, what are you gonna win? 6,000. So, you know, you don't. I mean, yeah, but if you bet on California Chrome, you're gonna win $2,500. Not much of a payoff, is it? So, I don't know. I'm not a gambler, so I don't know. I play the lottery. That's about it. Huh?
Maybe $1,500 you didn't have.
Yeah.
That's right. Always take free money.
Yeah. But that's your odds, and that's how you do it. Because a lot of people don't know what they're doing when it comes to odds. You find the odds against, and that's what you multiply it by the odds against right there. Okay? And that's a good problem, and that's a good test question also. So let's do one more so you'll have 2 in your handy dandy notebook. All right, there's number 2. Blow it up a little bit, Dana, please. $44 slots. I'm gonna let y'all do this one. Oh, me. After this one, we'll go look at them. No, you're not. I don't want. You sure? Oh. Somebody this morning took a black marker and marked all over the limbs of the. Well, I sent a thing to security. So I thought that I needed to do that since somebody's actually messing with the equipment. So I don't know if it. I don't know if it. I don't know if it was done at night. I don't know if it was done at night or early in the morning. All right, I'll tell security. Yep, you blame Bush. Bush did it. He came in here and did it. All right.
Dots, man.
What?
I mean, odds.
Odds again.
Yeah,
There's the probability of failure or the probability of success.
There's 2 dots.
Yeah. Means a fraction, it's a ratio. 4-over ratio. You can write a fraction like this. You can write a fraction as 3/2, or you can write a fraction 3/2, or you can write a fraction 3/2. So you could write the odds against as 17 over or 19 over 17 if you want. Four-over ratio. That's the episode on Andrew. Where Andrew's telling Otis we need to give to the needy because I was reading the other day, there's 2.5 boys don't have clothes or don't have so-and-so or don't have homes or whatever. They said, how can you have that? He said, what? A half a boy. Well, that's a ratio. 4 over ratio. And it's just the whole, just funny
Math
part.
thing,
Huh?
math thing, I guess. you
No,
know.
it's funny the way he says 4 over ratio. All right. So we got probability of success is probability of even. That's success is equal to 21 over 44. And then the probability of not even, which is our failure, is what? 23 over 44. So the odds against is equal to 23 over 44 divided by 21 over 44, which is 23 to 21. And then C would be the same amount, and then D would be whatever number times 23 over 21. So we'll go ahead and fill all that out. So that's 21 over 44. And that's 23, 21. And C, everybody should get right, if you can see it. $12. That'd be $12. If you miss C, don't tell anybody.
Hey, the answer part, they got that one.
What- Yeah, they got it right here, but that they got it wrong. Well, no, they fixed this one. No, how much profit do you make? Right there. There's the profit. That's wrong. All right. So what's 12 times 23 over 21? And that's how you do that problem. So you got 2 problems in there. That's 2 test questions.
Is that the knowledge? Is that what you're answering?
Yeah, that's the right answer. That word is wrong. It should say how much of a payoff, or how much is the payoff on a $12 bet. Payoff is $13.40. The profit is $1.14. But they use, I don't like that wording there. Question. Okay, we went over those. We've gone over the additive law. Have we went over the additive law? Or the multiplicative law? We haven't went over either one of those. Okay, well, we'll go over those today, but I want to look at some of the homework problems, because I don't want Miss Wilson to be behind on her homework. Right, Miss Wilson? You said you wasn't in a hurry. And I have no idea what kind of questions this book has y'all doing, so I'd get mad and leave too. See you later. Let's see. Ask my instructor. Miss Wilson, I think you ought to send me just a couple of more. You know what she does, y'all? You know what she's doing, right? She's getting me to do her homework. That's what she's doing. She does this every semester. I'm used to it.
No, to be honest.
I'm messing with you. Alright, let's see if we can find a question there with that. 7B. Have we covered 7B? I think we have. Let's see what it says. Okay, this is and. So this is the multiplicative rule. So I meant the multiplicative rule. I might just go over the multiplicative rule. Determine whether the following event is independent. Okay, let's go over before we do this. Let's just go over the two types of probabilities. All right, so far I've covered with you the probability and how to find the probability of success and what's the complement of the probability of success, the probability of failure. And we've talked about odds in favor and odds against. So what is the probability of pulling a king out of a deck of cards? What is the probability of not pulling a king out? There you go. So that's what we talked about the first part. For the last couple of days, that's what we've talked about. Now, the additive rule is the next thing. The additive rule of probability is when we see the word or. What is the probability of picking a blue marble or a red marble? Okay? And there's only one thing that you have to watch out with or and the additive property, and that is always, always subtract the overlap. And I wrote that in red so you would highlight it. And it's very important. Always subtract the overlap. So what I'm going to do is I'm going to pull up a problem. I like to pull this problem up because, let's see if I can pull up the 120 book. Yeah. And 4.3 is that section. See if they have one that I like. Okay. Here's the problem. Write it down. Blow it up a little bit, Dana, please. It says the following data summarizes the results from 932 pedestrian deaths that were caused by accidents. If one of the pedestrian deaths is randomly selected, find the probability that the pedestrian was intoxicated, or the driver was intoxicated. Can you imagine the driver being intoxicated and the pedestrian being intoxicated? I just think that's funny. I'm just imagining the pedestrian and the driver. That's just funny. I'm sorry. Huh?
Funny when they die.
No, it's made up stuff. Okay. See, are you leaving? Did I offend you? Is that what
No, I
happened?
have a meeting to go to. I'm really not offended, I promise.
Everybody's leaving me today. All right, so where is the word or? Right there at the end of the sentence. See, I offended her too. She's leaving too. Break it down a little bit. I'm just offending everybody. Everybody leave.
Can't laugh at that.
I know. Especially if they made up.
Yeah.
All right, so we've got the word or. Right there. And the word or, the pedestrian was intoxicated, or the driver was intoxicated. So that means if you put all these people's names and their condition on a piece of paper and put them in a hat, shake the hat up, they want to know what the probability, if you pick one name or one slip of paper out of that hat, They want you to know what is the probability of it being either pedestrian or driver being intoxicated. What you do is you take your highlighter, we'll take the red highlighter, and we'll highlight pedestrian was intoxicated. Then we take the blue highlighter, and we do the driver was intoxicated. Now, what is the denominator? Oops. And now we take our red, and that would be 100 plus 27. And we add our blue, which is 100 plus 98. And we subtract what? The overlap. And we'll make the overlap like a little orange or something. There's the overlap.
Because we can see it.
Hmm?
Because we can totally see which you, I like it.
Why? Always a critic.
That's pretty dope.
Oh, anything, princess. You messed that up too, didn't you?
We know it's amazing.
No, forget it now. I'm gonna fix it. There. All right. Now you just do the math. And of course that cancels one of the hundreds out. So you get 100 plus 98, that's 227. 227 minus 2 is 225. So 225 over 932. And somebody give me that decimal to 3 places.
0.241.
Huh?
0.241.
So you got a 24% chance of picking a drunk. So if you was to pull the name out, you got a 24% chance of picking somebody that was intoxicated. That is the additive law. So that is the word or. I want to do another one because sometimes you don't have an overlap. If I can find the problem that I want.
Can I ask you a question?
No. What?
Okay. Well, that's 27. You just took away 200. And how did you do that?
Well, you just go through and add them all up. 100 plus 27 plus 100 plus 98 minus 100. You can do it that way.
No, what I'm saying is, it was 100 and 227. So you took 200 from that and just took the 27 to the bottom of 100.
Okay, hold on. Let me find my problem. Let me find my problem first. Well, is it not on this page? Hold on, let me go to the... There it is. All right. I highlighted the intoxicated driver in blue. See that? And
Yeah, that's not the problem.
that's not the problem.
Change the name.
Don't do that.
I didn't type it in. Okay.
Don't worry about it. I asked you to do it.
No, go ahead and ask the question one more time.
Okay, on the last problem we had, intoxicated was 100, and then we had 227 to the bottom.
Mm-hmm.
Not intoxicated was 98 and 5%. Okay, when we do all that overlap and stuff,
Mm-hmm.
I'm assuming you subtracted 200 from the 27, which left 100 plus 27, worth parentheses, plus 100 plus 98, minus the 100.
All right. The 100 plus 27 was the intoxicated pedestrians. There was 100 here and 27 here.
No, it was 227.
Was it?
Yeah.
Okay, well then I messed up then. I'm sorry. I wish I could find the stupid problem. But evidently I changed it. I don't remember typing in an answer. Do y'all remember me typing in an answer?
There's no between it.
Yeah, but I didn't change it.
Yeah.
Okay, let's just do this one then. Okay? Let's just do this one. Good gracious. Alright, so we got, this one's asking, pedestrian was intoxicated or the driver was intoxicated. So, pedestrian intoxicated. Do that in orange. Driver was intoxicated. Do it in light blue. Halfway. Okay, so now we add up everything. And what is the denominator? The denominator is going to be 905. So they give you that. If they don't give you that, then you add it up. So that's the denominator. And the numerator is going to be 71 plus 218. And then the blue is going to be plus 71 plus 50. And then we're going to minus the overlap. Which is the overlap? 71. Now after I get out of this text writer, it will do it right. Hold on. There. So 71 plus 218 plus 71 plus 50, and then minus the what? The overlap. And I'll do the overlap in magenta. I'll just circle it because I don't want to cause it to. Oh, shoot. There. So the overlap is 71. And you subtract that. And somebody give me that number to 3 digits. .375. Does that help, Miss Whitson? All right. Go ahead and write that problem down, and that should help you. I didn't know I wrote down the wrong number. Tell me when you finish, Miss Wilson. Okay. Now the next one I want to show you is one like this. Now I'm not just don't even look at the I'll tell you what, let's just do this. Open, copy, Okay, forget that. That ain't gonna work either. Alright, let's just do this. Give me a second here. Let me see if I can find what I need to find. You can write down the problem. Go ahead and just don't write all of it down. Try to find something. What are y'all talking about? Huh? Dang it. That ain't gonna work. I don't know how to turn it off. Oh my.
What are you doing? What are you trying?
Leave me alone.
What are you trying?
I'm trying. Just hold on. I'm trying to just. No, I don't drink coffee. Somehow Spotlight came on. I don't know how that happened. I was just going to try to do one. Just write down the table. Okay? Just write down the table. That's all I want you to do is write down the table.
But you like coffee people, like the list.
I have put everything in coffee. I have put. You're not listening to me. I've tried everything. I've tried to put hazelnut. I've tried Irish cream. I've tried chocolate. I've tried vanilla. I've tried every kind of. Heck, there. I just don't taste coffee. I don't taste it. It tastes like hot water to me. And it doesn't make my breath stink if I don't drink it. Now you talking about some stinking breath.
That's why you brush your teeth.
You got to brush it every time you drink coffee.
I don't drink coffee.
Ugh. And then you put somebody that smokes Marlboro Reds with that. Oh, we used to have a drill instructor, Paris Island, and he drank like 5 gallons of coffee every morning, and then he'd smoke or eat like a pack of Marlboro Reds in the morning.
Do you get to call home when you're at basic training?
Not at Paris Island, no. No, we don't get to do anything at Paris Island.
You can write letters.
When I was at Paris Island, you couldn't.
This read your letters, don't
Yep.
Yeah.
They look at them.
they?
Yep.
They read their letters because how much you make.
Yep.
Exactly, you
What?
Is that like where all the Marines go, Paris Island? Or do the Army people go?
East of the Mississippi go to Paris Island. West of the Mississippi go to Hollywood. That's what we call them, Hollywood Marines.
How long do you serve?
10.
How do you get another
I didn't want to stay in.
Did you get deployed?
Did I get what?
Deployed.
Yeah, over in Desert Storm. I should
My
put all
dad's
that on the
friend.
information sheet, shouldn't I?
You should.
I should, and give it to all my
That would be good
students.
questions on our next test. I think
Yeah.
we should put that. Yes.
Mhm.
How many years did I serve?
Yeah.
Where did I serve?
But I have to give y'all a handout with all that on it.
No, you don't. You told us in class. There you go.
No, I should put a handout. Don't you think? What do you think, Vanna? I think I should put a
Okay,
handout
alright.
with the information on there, include my name and my, where I'm from and things like that.
I forgot, alright? I'm sorry I didn't study your life off your syllabus.
We're gonna make a movie about your life.
We'll call you American Marine instead of American.
Yeah.
What were you in
EOD,
It's a whole
Yeah,
war.
what is
explosive ordnance disposal.
You gotta blow stuff up.
Not everybody that goes over there has to fight there, right? They can be on base, right?
They
So
could
it'd
be
be
on-
like a version of, what was that movie?
That was a fight.
Jeremy Irons in it, and he played,
My dad's brain
It wasn't a
dead.
bomb day, but he disarmed what are those things called that they had?
Detonator?
The Hurt Locker, yeah. Make a version of Hurt Locker for use to disarm stuff.
My dad.
All right. You can make a mine out of a Copenhagen can.
Gotcha.
All right.
One thing is that, like, the 6 months
Hang on. Toothpick, C4, and a snapper pop.
Huh?
Put it on the ground, blow somebody up. Real easy. All right. I want the probability of 22 to 29 or 40 to 49. Okay, so there's the word or. So I'm going to highlight 22 to 29. And highlight 40 to 49. Is there an overlap? No. If there's no overlap, you don't need to what? You don't need to subtract it. So you may get a question that asks you something like this. What's the total? Or they don't give you a total, so you have to add all those up. Somebody add them all up. What do you get? Tell me when you get it all added up. How much? 1,243. And then 255 plus 22 is 277. Plus 150, 164. Y'all check my math. Is that 277 and 164? Yes, no, maybe. What? All right, and what does that come out to be? Give me 4 decimal places.
0.354.
0.354. Okay, 4 decimal places. So the probability of 22 to 29 or 40 to 49 is a 35% chance, or 0.35 probability. So when you see the word or, what? I know. Have a fit. When you see the word or, you're going to use what? Adding. When you see the word and, different story. Yep. The multiplicative rule what? Multiplicative. Impress your friends. The multiplicative rule revolves around the word and. Now the only thing that you have to remember about the word and in the multiplicative rule is with or without replacement. Remember this out of 120?
Yes.
Now, after 3 digits, it doesn't matter. 3 digits or more, the higher the math, the more it doesn't matter. time when you're having something about votes, like voting, or having to do with dead bodies or anything having to do with bodies, like a senator voting or people dying. You can't die but once. You can't vote but what? Once. Even though Mickey Mouse and Donald Duck voted in the last presidential election. You shouldn't be able to vote but once. Huh? Although Mickey Mouse and Donald Duck voted in the last presidential election. Y'all watch the news at all? Well, you better start watching it. Oh, okay, yeah, I'm
I
sorry.
don't have a life, so I watch
Okay.
it.
Anyway,
I watch it in my car.
there's a lot of voter fraud that went on in the last two presidential elections. And that's why a lot of people have been pushing for voter ID. You can't vote unless you show an ID. I mean, you show your ID to get your check cash. You show your ID to, get carded. Well, in South Carolina you do. But in other states you don't have to, and they were saying it's racist if you ask for an ID.
What?
I might be ready to do this next time.
I don't
I don't think it's
know
anything.
why.
I'm just asking for identification.
What? With or without replacement. Let me give you an example. And I always do the marble bag. Dang old bag of marbles. I can't draw, but
That's a good time.
okay. No, it's not. Because Miss Wallace will make fun of it. So. Alright.
I ripped off the room.
What did she say?
I ripped off the room.
You got something to say about everything, don't you? Alright, in this bag of marbles, you got 4 red marbles, 3 blue marbles, 5 green marbles, and 7 yellow marbles. So you got what, 19 marbles? Alright. Now, if you want to know what is the probability of picking 3 red marbles, well, there's two ways to do it. One is to just say, how many red marbles are there? 4. 4 out of what? 4 out of 19. And you pick how many times? 3 times. 3 red marbles. Okay. So somebody do that math and give me 4 decimal places. 4 divided by 19 and raise it to the third power. What do you get? Change it to scientific. 7 in scientific. Down in the bottom of the menu,
I got 0.009. I cracked my phone this thing.
.00 what? 009 even?
Well, 932
Okay.
0
Alright, so .0093. Now, what I just did is I just said I'm going to pick a marble, put my hand in the bag, I'm going to pick a marble, then I'm going to put it back, I'm going to write it down and put it back. Then I'm going to pick a marble, write it down, put it back. Then I'm going to pick a marble, write it down and put it back. That is without replacement. The exponent is without replacement. Or with replacement, sorry. Look it up in your book. It'll tell you what the word independent or dependent is that goes with replacement. I don't remember that. I just with replacement. Now, the other way to do it is without replacement. 4 divided by 3 over 19 times 3 divided by 18 times 2 divided by 17. What did I do? I put the marble in my pocket when I picked it out. I picked one, put it in my pocket, and that left how many red marbles? And how many in the bag? Picked one, put it in my pocket. Now, multiply those out and see what you get. Now, they'll give me 4 digits. I would use parentheses if you got a TI. Parentheses 4 over 19, close parentheses, times parentheses 3 over 18, close parentheses, times parentheses 2 over 17.
I know it's gonna be a test for.
Yeah. Why? I'm showing you 2 different ways. I'm not going to ask you both ways. I'm going to ask you one way. 0.0041. Is there a difference?
Yes.
Why? Because we're talking about single digits. All right. Now, if you're talking about triple digits, you're not going to see much of a difference. This is with replacement. This is without replacement. All right. My tummy's hurting. And I got to go to the doctor at 11 o'clock, so I'm going to call the class off and